Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be deriving the Clausius-Clapeyron equation. So the problem tells us to show that the Clausius-Clapeyron equation, which is a modification of the Clapeyron equation specifically for vapor-liquid equilibria, is given by ln of P2 over P1 is equal to the negative delta H over R multiplied by 1 over T2 minus 1 over T1. So here, in the problem, it stated that the Clausius-Clapeyron equation is a modification of the Clapeyron equation. So it only means to say na doon tayo magsisimula to derive this equation. And what is our formula for the Clapeyron equation? We know that it is dP over dt is equals to delta H over T delta V. And we know that this delta H and delta V, it signifies the difference between the enthalpy and the molar volume, respectively, of the two phases that are in equilibrium. Okay. So here, in order for us to modify this equation, we have to make assumptions. So the first assumption that you have to make is that the molar volume of the substance that is in the liquid phase is a lot lesser than the molar volume of the one in the vapor phase. And that means to say that VL is lesser than VV. Okay? Therefore, the difference here, delta V, this one is actually delta V liquid volume, for liquid volume, right? And is equivalent to VV minus VL. And since VL is a lot lesser, it is negligible. Therefore, we can cancel it off. And this one is equivalent here. So this one is actually will be replaced by the molar volume of the one in the vapor phase. Okay? And since now we're only taking into account the one that is in the vapor phase, we have to assume another factor here. And we have to assume that the vapor is an ideal gas. Okay? And what is our formula for ideal gases? We know that it is PV is equals to nRT. Okay? We're gonna make the molar volume the subject of the equation here. And we know that molar volume is V over N. Kasi it's the volume of 1 mole of gas. So V over N is equivalent to RT over P. And what we're gonna do next is we're gonna substitute this. And this one is equals to this here in this equation. Okay? Which is equals to V or V. Okay? Now we just have to substitute this value or this fraction here into the Clapeyron equation. So therefore, the equation becomes dP over dt is equivalent to delta H over T, and then our V is equals to RT over P, right? RT over P. Okay, and since this one, there's a fraction here. This one goes to the numerator. So the equation becomes dP over dt is equal to delta H over delta H times P over R and then T squared kasi there's two T's there. Okay? Bakit napunta yung pressure at the denominator of the denominator sa numerator? It's like this. For example, let's think of it mathematically. For example, you have a fraction here. Let's say 1 divided by 1/3. How do you calculate for this? If you have a fraction inside of a fraction, then you transform it into the most fundamental mathematical operations that we use, that we've learned from the beginning, right? So alam natin na 1 is divided by 1/3. And since we can't really divide a fraction, we have to turn it into multiplication. And what does it become? It becomes 1 times, and then this one, you take the reciprocal of it. It's 3, right? Therefore, it is 3. And we can say that it is because the 3 is moved to the numerator. That's why it became 3 times 1 over 1, and that is equal to 3. And that is the same principle that is applied in this transformation here. And now what we have to do is we just have to put the differentials and the variable that is corresponding to that differential on one side of the equation and the rest on the other side. So we know this one is dp, right? So yung dp, mariretain siya. Because this one, transpose natin to the other side of the equation. So it will be at the denominator this time. So dp over p is equal to delta h over r t squared. And then yung dt at the denominator on the left, it will be on the numerator on the right when transposed. So it'll be dt, okay? And we know, we've learned from calculus that the integral of dx over x is equals to ln x. Likewise, the integral of dx over x squared is actually, we have to simplify this here. So we know that dx over x squared, integral of that, it's actually equal to x raised to negative 2 dx, right? And we know na kapag ganito yung differential mo, ang rule ng calculus natin is you have to add 1 to the exponent, and we have to put that exponent to the denominator as well. So what I'm talking about is it will become like this. It will become x raised to negative 2 plus 1 over negative 2 plus 1. So it will be x raised to negative 2 plus 1 is negative 1 over negative 1. So simplifying that, it will be negative x raised to negative 1. Okay, so taking the reciprocal will be negative 1 over x. Now that we have found the integrals, or now that we have recalled how to integrate, we have to apply it here. So dp over p, let's say na there's a boundary p2 and p1 here. So p2, p1, ln dp over p is equals to delta h over r times the integral of dt over p squared. Okay? So now simplifying that, we have ln p2 minus ln p1 is equal to delta h over r, and then this one, right? So it will be negative 1 over t. Negative 1 over t bound from t2, bound from t1 to t2, sorry. Okay? And now what we're gonna do here is simplify. So we know that from the laws of logarithm that it will be equal to ln p2 over p1. Okay, and then this one, mariretain siya. Actually, ilabas natin yung negative sign here. It'll be negative delta h over r. And we have, we just substitute this boundaries here. So 1 over t2 minus 1 over t1. And that is our answer for the problem. Let me just rewrite. It'll be ln p2 over p1 is equals to the negative delta h over r. Kasi nilabas natin siya here. Multiplied by 1 over t2 minus 1 over t1. And that is our answer for the problem. We have proved that the Clapeyron equation is indeed like this. Okay, if you want to take another form, you can actually distribute the negative sign here inside here. So it'll be ln p2 over p1 is equal to the delta h over r. And then dito, madidistribute natin siya inside. So, negative 1 over T2. Negative 1 over T1. So, simplifying that, it'll be ln P2 over P1 is equal to delta H over R times. This one will be positive 1 over T1 minus 1 over T2. So these are the same, it's just that we distributed the negative sign. And that is our formula for the Clausius-Clapeyron equation. So I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.